Now here's a really useful method in differentiation, in differential calculus, implicit differentiation. I hope you appreciate the very pleasant background I've given you there. Unfortunately, that's not the background I'm really talking about. I'm talking about going back to previous examples and what we would have done without implicit differentiation. So here's example 1. We have dy by dx equals x into y minus 1. X into y minus 1 equals 3x minus 2, and we have to find dy by dx. Now, all the ones we've done so far start with y equals, f of x equals, and so this is pretty strange getting it like this. And the first thing we're going to have to do is write y as the subject of the equation. So multiply out, and this is really from grade 10, this method. Collect the y's on one side and x's and constants on the other. Common factor of y coming out, and then divide by the x minus 3. Now be careful, because at this stage often we forget and we move on to the next question, but we haven't differentiated yet. We've only written it in a form where it's easy enough to differentiate. Now we can use quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared, and we get our final answer. Let's do another example. This one's a bit more stretching. We have y squared there and xy there. Now this is where we often have to use implicit differentiation. In fact, it's usually easier if x is multiplying with any power of y, or you have any power of y other than y to the 1, then it's pretty much standard to use implicit differentiation instead of normal differentiation. Right, so let's have a look first. This is still the background, so I'm going to have to write y as subject to the formula. The only way I can do that is to use this as, see, this is a quadratic equation. So there we are. I've written everything on one side with a 0. There's my a value of a, 1. The b is the number multiplying y, so the b is x. And the c is the number independent of y, and there it is there, minus x squared minus 1. And I substitute it into quadratic formula. Notice, don't worry, you won't be expected to do this, because we're going to use implicit differentiation, which I think you'll quite enjoy. It's quite intriguing. So I'm now simplifying, that's all, and I've got it down to there, minus half x plus or minus the bracket to the half. Now here we have to differentiate still. There are two terms, so we differentiate. The difference, the derivative of two terms is the same as taking the two terms separately and differentiating them. So that's minus x goes to minus half. That's easy enough. The second term is a, the second term is a chain rule. Outside function, something to the half. So therefore I've got half, that's something to the minus half. And we leave the inside exactly as it is. Multiplied by derivative of the inside. So derivative of the outside times derivative of the inside. There's 10x as derivative of 5x squared plus 4. And we simplify. Fairly complex mechanical maths there. Now we're going to have a look at implicit differentiation. Here's the principle it uses. We use the principle, what you do to one side of the equation, you do to the other. Be careful, it doesn't always work. For example, if you have sine of f of x equals sine of g of x, or any trig ratios, then that doesn't, if something equals something and you take sine of both sides, that's not necessarily equal. So let's have a look here. I mixed that up actually, but trigonometry, you couldn't do that. Anyway, often it mixes up. Don't worry, what I said wasn't true. I'm being an idiot today. Right, but f of x equals g of x. I can then say the derivative of the left-hand side equals the derivative of the right-hand side. That's definitely true. Left-hand side equals right-hand side, then the derivative of the left equals derivative of the right. So if we take that x squared minus 5x, if we take an example of x squared minus 5x, derivative of the left, d of y by dx, equals derivative of the right, d of x squared minus 5x by dx. Now, when you differentiate the y, we're going to get dy by dx. And when you differentiate the right-hand side, there we are, that there, we're going to get 2x minus 5. Now, that's a straight differentiation, this one, but I'm showing you if we think of using implicit differentiation, well, that's exactly what we are doing at the moment. We have done so far. Now, let's have a look at one which will be more useful, where the implicit differentiation will be more useful. xy equals 2x minus 5y. Now, we can write in terms of y. Again, we can make y the subject of the formula, but let's use implicit differentiation. So what I'm going to say is derivative of the left equals derivative of the right. Now, I'm going to differentiate the left, and I'm going to differentiate the right. So derivative of xy equals derivative of 2x minus derivative of 5y. Note, as this is differentiation with respect to x, the by dx means with respect to x. We differentiate any x's as usual, so 2x will go to 2. And that's fine. But y has to become dy by dx. So if you differentiate y, it becomes dy by dx. We did just that. If you look at the previous one, there we are. Derivative of y by dx. We went the next step and we said dy by dx. Right, let's go back to this one again now. Right, y becomes dy by dx. Now, the interesting thing is, if you have any function involving y, that will be a composite function, and it has to be differentiated by chain rule with y as the inside function. So if we're differentiating x, it goes to 1. If we're differentiating x squared, it goes to 2x. If we're differentiating y, it goes to dy by dx. If we're differentiating y squared, we have an outside function of something squared and an inside function of y. So the outside derivative is 2y. Multiply down by 2 and subtract 1 off there. Leave the inside exactly as it is. Right, so we're leaving y exactly as it is. Times, and the inside function is y, and the derivative of y is dy by dx. So it's almost like twice a bracket squared. So we differentiate the bracket, 2 times the bracket as is, to the 1, and the as is the y. And then we've got to differentiate the inside of the bracket, which in this case is the y. So now, here we go, product rule. Derivative of the first times the second as it is, plus first times derivative of the second. So that's dy by dx, derivative of y with respect to x, equals 2. And derivative of 5y with respect to x is 5 times dy by dx. Now we can solve for dy by dx. dy by dx is to one side, everything else to the other. Common factor of dy by dx, and divide. And there's nothing wrong with having y's as well in the actual derivative. We'll come on to that later. You'll see why that is the case. Let's go back to the number 1 we did, this one here. Now remember, we multiplied it out and then made y the subject to the equation. Let's rather do it by implicit differentiation. So I multiplied it out anyway, just to make it a bit simpler. Now, derivative of the left equals derivative of the right. You don't have to put this step in. So derivative of xy minus derivative of x equals derivative of 3y plus derivative of 2. What we're saying, in other words, is in implicit differentiation, we differentiate each term throughout the equation. There are 1, 2, 3, 4 terms, so we differentiate each term. 1, 2, 3, 4 terms, so we're going to differentiate, 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 differentiate. Now the derivative of xy, that's a product, same as we had in the previous question. Derivative of x is 1 and leave y, plus x times derivative of y, which is dy by dx. Derivative of x with respect to x, 1. Derivative of 3y with respect to x, 3 times dy by dx. And derivative of 2 with respect to x, 0. Take out, I've jumped a step there, I've brought across the dy by dx and take the y to that side. But take out a common factor, divide, and there is our derivative. It's actually the same answer as the previous one when we did it, but just in a slightly different form. Going back to number 2, that's the one where we had to use a quadratic equation in terms of y, and use quadratic formula. Now we're going to use implicit differentiation. So we're going to multiply both sides, which means, we're going to differentiate both sides, which means we differentiate, 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 differentiate. We differentiate each term. So y squared differentiated by chain rule, outside function, something squared, so it's twice that something. Inside function y, so we differentiated dy by dx. Derivative of outside, 2y, times derivative of inside. Derivative of x squared is 2x. Derivative of xy, there we go, derivative of x times y, plus x times derivative of y, plus 0. We don't have to write that, but I'm showing so that it's not lost along the way. Multiplying out, bring dy by dx to one side and take out a factor, common factor of dy by dx, and divide. And there is our derivative using implicit differentiation. Let's have a look at another one now. Xy to the 4 plus x to the 4y equals e to the x plus y. I challenge you to make y the subject to the formula here. Let's do it by implicit differentiation. Once again, you don't have to write this step. You can go right to the next by differentiating each term. So there we are. Derivative of xy to the 4, derivative of x times y to the 4, plus x times derivative of y to the 4, which means 4y cubed, differentiating the outside function, times dy by dx, the inside function. X to the 4y, so we differentiate x to the 4, 4x cubed, times y, plus x to the 4 times derivative of y, which is dy by dx, equals derivative of the outside function. The outside function is e to the. So we're going to say e to the x plus y, because the derivative of e to the is e to the. E comes back as the same thing. Derivative of e to the x is e to the x. Then we have to multiply by the inside derivative of the inside function, which is derivative of x plus y. So differentiating x plus y, we get 1 from the x and dy by dx from the y. Now we're going to multiply out, collect terms with x plus dy by dx's, common factor, and divide. And there is our derivative of that expression using implicit differentiation. Another one, sine of x plus y equals x minus y. I challenge you once again to make y the subject. You see, we have to use implicit differentiation. Derivative of left equals derivative of right. Once again, I'll say to you, you don't have to write that step. So therefore, derivative of sine of x plus y. The outside function is sine, so therefore derivative of the outside is cos of x plus y. And derivative of the inside, 1 plus dy by dx, equals derivative of x is 1, derivative of y is dy by dx. Multiply out, collect dy by dx's on the one side, common factor out, and divide, and there is our derivative of that expression in terms of x, or dy by dx. Here are some examples for you to do. Do them before we go on to the next step, which is answers. So pause. Right, let's go on to the answers. Number 1, multiplying out first. The reds, product rule, and differentiate the x separately. The 3y squared is differentiated using chain rule. And minus 2y becomes minus 2 times dy by dx. Collect, take out a factor, divide. And there is our derivative for the 1.1. 1.2. Derivative equals derivative. So 2x plus, and of course this y squared has to be differentiated by chain rule, so outside function is something squared, so it's twice the summing, times derivative of the inside, and the inside is y, so it's dy by dx. Derivative of the constant is 0. Solving for dy by dx, we get dy by dx equaling minus of x over y. Number 3, y squared, we have to use chain rule. X squared y, well, that's the product rule. Derivative of x squared times y plus x squared times derivative of y minus, don't forget to put brackets for this because we're subtracting, product rule, derivative of x times y squared plus x times derivative of y squared. And that's chain rule. And then minus 1 for the by x and minus dy by dx for the minus y. Multiply out, collect and take out, collect dy by dx terms, take out the common factor, and divide. The final one, xy cubed, differentiate. We take the derivative of each side, and when you differentiate a difference, it's the same as difference of the derivatives. When you differentiate a sum, it's the same as sum of the derivatives. Product rule. Derivative of x times y cubed plus x times derivative of y cubed, and its chain rule. Minus 4x, derivative of minus 2x squared. xy, we have to differentiate by product rule, derivative of x times y plus x times derivative of y. And the 4 is gone because derivative of a constant is 0. Collect the dy by dx's, take out the common factor dy by dx, and divide. Very interesting method.